Okay, so what I'm going to demonstrate here is um, making a regression model to predict an outcome. And what I'm going to use is this green variable here, GPA, as my outcome. And I'm interested to see how these 5 possible predictors might be able to explain variation in GPA. And I know it's going to be very imperfect and it might not work, but it will illustrate this general sort of strategy. So what I'd like you to look at is here's a sort of conceptual model, thinking that maybe family SES, mother's education, and father's education are the earlier variables, and then the causal direction is going here to the right towards GPA. So mother's ed, father's ed, and family SES might be representing sort of both resources and opportunity to do better in school, and then also sort of a cultural capital sort of idea that families that got further along in school might be valuing education more because the mother's ed and father's ed are like level of schooling completed. So those could be shaping both how far the student goes in school, so this is their academic class status at this point, the amount that they put effort into their studying, and then their GPA as a result. Now we know that GPA varies also widely between disciplines, so we know there's a lot of error introduced there, and there is some sort of theoretical background for expecting families with more educational and kind of material socioeconomic status to result in students being more successful in the education system, but that not going to be a very strong relationship. We might want a better dependent variable. Maybe it would be a subsequent job of students or whatever. But anyways, this is what we're looking at now. And so if I go here, then what I want to do is I want to think about GPA as the outcome, and then these 5 variables as the possible causes or correlates, right, that we're using to predict GPA. So under add-ons, if you get this free statistics package, you click on regression, pops up this little thing over here. You specify which sheet you're using for data to input up here at the top. I've already selected Explore, which is where these variables are. And what you would do is for the response variable, which is the dependent variable or the outcome, you would add that choice, and it happens to be GPA here, like that, okay. And then you would add predictors, and if you scroll down here, I can then just go through and hold Control and then click on all of them, and then hit OK of the predictors right here that I wanted to use. And then I choose Create, and it makes regression here, regression 3, and I can go ahead and close this. And what do we pay attention to? Well, the first things we pay attention to is the model fit. The term R² refers to the amount of variation in the dependent variable that is explained by variation in the independent variables, or the predictors. Adjusted R² is a version of R² that penalizes a model for every variable it includes, just because just to random luck, things will end up being a little bit correlated with other things, and so that baseline little bit of correlation is estimated, and then you take that away from the amount that you've explained. So we can see that the R² is 0.085, so we've explained 8.5% of the variation in GPA by using these variables we have, which is not that great, but I guess it's not nothing. But the adjusted R² is 0.05, meaning that we have variables included in our model that are not really boosting our explanatory power as much as we're being penalized for them because of the drop of about 3% between R² and adjusted R². So that's the first thing we would look at, right? So I could highlight that. Let's see. So you want to look at these there. And the other thing you're going to look at are the estimates and then the probability, but you can also look at the standard error. All of these things are going to be telling us some related bit of information. So I'm just going to put green on those. So the estimate is the predicted GPA, actually, based on the model, and then we can adjust that prediction based on the values of these variables. And so for every 1 unit increase in subjective SES, the predicted GPA goes down by 0.089. And then for every increase in maternal education, it goes down by 1.56. And for every increasing unit in paternal education, it goes up by 293. So one of the things we can notice right away is that when you take into account the other variables, the direction of effect of a particular variable might go in an unexpected direction. And the reason is that we're taking into account father's education. The influence of mother's education is negative, even though probably if we just did a simple model where mother's education was predicting GPA, it probably would have a positive relationship. But this is after taking these other things into account. So that's one sort of important thing to remember. The other thing is that if we look at the estimate, let's take mother's education, for instance, and compare it to the standard error. The estimate is what we would call the systematic effect, the systematic influence of that variable on the dependent variable, taking the other things into account. And then the standard error is the random noise, the variation that we can't explain. So what we can see here is the systematic effect is 0.15 and the random error is 0.09. So the random error is about 2/3 as large as the systematic effect. And so what this means is that the systematic effect is not that much bigger than the random noise. And so that means the probability of observing a systematic effect in the sample and having it not be occurring in the population is like 11 out of 100, 11% of the time you'd see that, which is actually pretty likely compared to the standards that we would like to have. So unfortunately, this means that this predictor, mother's education, is not a significant predictor at the sort of thresholds that we would think of the minimum. So a 5% chance would be the sort of minimum we would look for. But we can see that father's education here is significant, and we can see that the estimated effect is about 0.30, it's 0.29, and then the standard error, the random noise, is 1/3 of that, right? And so that's a signal that taking these things into account, the father's education ends up being the best predictor of the variables that we've included. The other thing that we learn in general is none of our predictors are that great at predicting our GPA, which we're not that surprised by because we know that GPA varies for lots of things other than the reasons that are represented by these variables. It is interesting to see that study time has no relationship, basically. Like so the systematic effect is 0.08 and the random error is 0.056. So the random error is almost as big as the systematic effect there. And then for year in school, the random error is twice as big as the systematic effect. So although it's probably good to have that in as a control variable because there might be important differences, and then it might allow the other variables to have more of an effect. We didn't look at the intervening models. Like we could have added one variable at a time and seen how the estimates were changing as we're going along, but we didn't do that in this case. So the sort of punchline that we might get from this is this was the model that we were wondering about. We were wondering about if each of these lines, we weren't measuring these in-between lines, we were just measuring direct lines from each of these predictors to GPA. So it would look like a bunch of straight lines going in there. We might imagine these other things going on, but really we're looking at straight lines. And in this case, the only thing that ends up having a significant effect after taking everything into account is father's education. So father's education is having a positive impact on GPA, probably through study habits, expectations, resources, other things like that, that are going to be related to having a father that has a higher level of school completed than others. Okay, so what we did is we ended up, we started with our data here, and we identified what we thought would be logically sensible variables to predict an outcome, and we chose variables that here especially, right, these are prior to, they occurred before GPA. Of course there's going to be a reciprocal relationship between GPA and study time, and there's also kind of a relationship here between program progress and GPA. There's going to be people dropping out, so they're not going to be there. So it's imperfect as if you wanted to take the rule that all causes have to be prior to an outcome. There's some reciprocal relationships maybe between these three. But anyways, these sort of made sense. We didn't expect to explain a lot. We explained a little bit if we look at our regression results here. What we probably could do is eliminate some of the variables that aren't apparently as important as we thought they might have been, and end up with a variable with fewer predictors that has a better overall fit. But that wasn't really our goal to maximize the fit. It was more just to see of these variables that we thought might be related, when we take them all into account, which ones are the best predictors. And so what we learned, which was somewhat interesting, is that the father's education variable was the only one that had a significant and positive relationship to GPA after taking the other ones into account. So this would be the sort of stuff that you could talk about, this sort of reasoning about how the different variables are influencing the outcome or not would be something that you could discuss in your papers.